Okay, class, good day. Welcome back sa ato ang course, ato ang discussion on finding the potential given a charge distribution using a special technique. And we are still on the monopole and dipole terms. We'll continue with our discussion on that. And previously, naka-calculate ta, di ba? Naka-derive ta sa general formula of uh, finding the potential of a charge distribution in terms of powers of 1 over r. So it turns out nga ang potential di can be summed up into individual bits or components. So we have the contribution or component for the monopole plus the component or contribution sa dipole for the quadrupole and so on. So if you account all those contributions, your potential actually is exact. Okay, exact na siya. But that can also be used as a good approximation if, let's say, when you want to know the potential as viewed from a very far distance. So, unsa ka ang mga mo dominate ng mga terms, and maybe we can safely neglect those terms that that meaning its value falls off very rapidly. For example, if ang mo dominate lang a portion sa imong potential, ang contribution lang is more on the monopole, then the rest can be neglected, or maybe dipole lang or monopole dipole. So in other words, you can actually have a very good approximation, so your potential becomes more accurate or close to the exact solution if you include those terms. Okay, so it's like approximating something in greater accuracy. Okay, so let's continue with our discussion on monopole and dipole terms, and I will be looking out unsa ka ang electric field for the monopole and dipole nga mga entities. Okay, let me just turn off my video. Okay. Okay, so ordinarily, oh, so ordinarily, any charge distribution or multipole expansion is actually dominated by the monopole term. Okay, so the multipole expansion is dominated. The rest kay pwede siya ma-neglect, okay? Or ma-crush out sa equation. So we have the potential for the monopole term. We have the mon for the monopole. And it's given by this 1 over 4 pi epsilon naught, where Q is the total charge, and then R. Okay, so Q of the total charges could mean anything, right? Could be just the total charge. Pwede siya point charges or pwede po siya charge distribution. So let's say charge distribution siya kay mas general. So that is equated to this one, the integral of rho d tau, right? So rho prime d tau prime. It could be that the total charge could be pwede po siya, this is volume, pwede po katong area, di ba? I have sigma dA prime. Or it could be a line charge, right? Okay. So, kani siya is, well, approach siya into this, right? If one views it from a very far distance, okay? So, the monopole will actually dominate. Okay, the rest can be neglected. But incidentally, let's say dili siya actually charge distribution, but literal gid siya nga point charge. Let's say you have a point charge, and then as viewed from a very far distance, what would its potential look like? It's actually the same gihapon for this formula. So if we use our general formula, katong summation bitaw that includes the monopole, the dipole, the quadrupole, octupole, and so on. For the case of point charge, the monopole term is actually the exact solution na siya. Okay? Okay, ang katong dipole, quadrupole, and octupole, they don't make a contribution man sa point charge because it's a point charge. Okay? So in this case, the monopole is not actually katong kung kaon mo ang first term lang, the monopole is not actually an approximation, but it's in an exact solution because, as I've said, it's a point charge in the first place. Okay, so for a point charge, the potential for the monopole term, this is actually the exact solution. Okay? Not an approximation. This is only for a point charge. But for a charge distribution, of course, this would be an approximation. Okay? I-approximate mo siya ang charge distribution into a monopole term lang. Okay? So for a point charge, there is no other higher multipole. It vanishes. Okay? So that would be the case. But however, if not one charge, say two charge, maybe four kabok charges, basta kay ang total charge niya is 0, of course, the leading term for that is the dipole. Okay? If the total charge is 0. So the dominant term will be the dipole term, katong sa summation. If you can recall sa katong summation na to, right? In terms of the gender, kung ano man to siya, na contribution sa monopole, dipole. So for this case, it's just the dipole term, let's say, ang dominant niya. So we have dipole. The formula for the dipole, the second term, ato is given by this. So it falls at 1 over r squared, ang iyang potential, right? Then the dipole moment is given by r prime cosine theta prime. Okay? I hope inyo na siyang i-recall, tanawan nyo sa atong formula. Recall the general formula. And then look at the second term. Katong dipole term. Okay? Ano siya ang formula. Okay. So, if atong i-drawing to balik katong dipole, di ba ana man to ang dipole? So, you have positive q, and this is negative q. And this is distance d. And then, in between is d over 2. D over 2, right? Tapos, na ako at point P. That's where the field point niya kung gusto i-determine ang potential diha. Okay. Supposing na straight na siya. Then this is r plus, this is r minus, this is r. Right? And then we assume nga ang r is much greater than d. That's why naka-derive ato na siya na-derive before. Gamit ang mga approximation because of this condition nga r is much greater than d, and then we solve for the general formula for the potential in terms of dipoles, monopoles, right? In terms of 1 over r. Tara. Katong general formula. Okay, and for the charge distribution, we have this katong, di ba anak man to? For a general formula. This is for dipole only. So for the general formula, na ko volume element diha. right? The tau prime of density r prime. Tapos this is my origin. And then, ang vector nga mag-point padulong diha, that's actually r prime, r prime, then my field point, right? Then from the origin to the field point, again, we have r, and then this one is r, right? And then the angle between the r, this one, and the r prime, and the r is actually theta prime. And we already solved this one. That's why nataan nga formula. Yeah, we have r prime cosine theta prime rho r prime d tau prime. Okay. And then note that, so i-note nimo nga ang since theta prime is the angle between r prime and r. So we have, so we can siya, right? Kung i-draw balik, so we have r prime, then we have r. So this is theta prime. So if we get the dot product of that, so we have r prime dot with r. So from our vector analysis nga lesson before, that is actually given by the magnitude of r, r prime r, cosine theta prime, right? AB cosine theta, the general theta, AB cosine theta, the general formula for that. Okay? So we can simplify this one. Atong i-retain ang r prime cosine theta prime, wherein ang r is atong ibalin sa pikas, kaning r. So we have r prime over r over r, or magnitude. So in a way, that would equate to r dot with r hat over r is just this prime. Okay, r arrow over r is just the r hat, or the unit vector, right? Akong tarong magsulat. So this is r hat. Okay, so therefore, this r cosine theta prime here, that would be equated to this, right? So r prime dot r hat na siya. Okay, so the dipole potential becomes, we have dipole, so that would be 1 over 4 pi epsilon naught 1 over r square. So isubstitute nimo ni siya kaning formula sa imong integral, right? So we have r hat and then dot with the integral of r prime, right? Rho r prime d tau prime. Okay? So I hope naka-follow na siya. And this entity, so kani siya nga factor, we can define this is actually defined as the small p arrow, or the dipole moment. Okay, so that's the dipole moment. So this is dipole. Okay. The dipole moment, and this dipole moment depends on the size, because as you can see, the dipole moment is just is the integral of the r prime and the charge distribution, yung density. So of course, madepende siya sa size, kung spherical ba siya or cylindrical or line charge. So depends on size, shape, and density. Okay, that's for your dipole moment. So simplifying this one, dipole, we have 1 over 4 pi epsilon naught r hat dot with your dipole moment over r square. Okay, so this is your formula. The simplified version sa imong potential, the dipole potential. Okay, and that is found to be equal to this. That is the r hat, the unit vector r, dotted with your dipole moment, which is given by this equation over r squared. Okay, so let's say this is also applicable if your dipole is not a continuous charge distribution but point charges. So we can actually recover katong result nato before nga itong i-calculate sa itong previous video. So dipole moment for a collection of charges is, so gamit ta nga formula. This is the dipole moment. Instead na integral, that would be summation, right? So that would be given by this. I runs from 1 up to, let's say, n. So that would just be your charge. Instead not rho or sigma or lambda, point charges man siya, so discrete. So we have q sub I times the distance, r prime I. Okay? So if you have a dipole, actually na ay two types of dipole. We have the pure dipole and the physical. So the pure dipole is very, lisod na siya ikuan sa actuality because a pure dipole is like, it's kinda, mo siya na mahimo na siyang point bitaw ang pure dipole kay baga viewed from a very very far distance, it's as if ang imong dipole is like a point na, so what happens to the distance between them? So gamay na kay ang, di ba usually ang dipole ana man na siya, you have the plus and the minus q. So for a pure dipole, this distance between them is very very small, so i-shrink nimo siya, and to compensate for this pag-shrink sa distance, your q must be very very big. Okay, so dapat dako kay siya, so to maintain the same value. Okay, so we have qr, so this is very very small, so di man pwede nga ang imuhang dipole is 0, right? Approaches 0, so kanimo dako po din siya. So that is your pure dipole. But in reality, we have your physical dipole. So most probably when someone say a dipole, he or she is probably referring to a physical dipole. So this is the physical dipole, na siya physical distance between them. So we have a plus q and a minus q. Later on, we'll determine ang iyahang direction electric field between a pure dipole and a physical dipole. So for a physical dipole, kani siya, the physical dipole, we can calculate its dipole moment given as, so we have positive q, yeah, we have r plus, di ba? Katong this one, kani, we have r plus and r minus. Okay, plus so it's actually minus na kay ang isa kay minus man. So minus q r minus, and then common ang q, so we have r plus minus r minus, where r plus or r minus just d, right? Katong distance nga d between them, this one. So this is just qd. Okay, And if you substitute this one, this to this, so your V dipole would just be 1 over 4 pi epsilon naught r hat. Ang pili mo is QD. So actually, this is arrow vector over r squared. So that would be 1 over 4 pi epsilon naught. R hat that D hat would be cosine theta, right? So we have Q D cosine theta over r squared. Okay. So if we go back sa katong formula nato nga nag-example without that, it's actually the same. Kani siya nga. So it is consistent. So you can review your notes or the previous video wherein na-calculate atong kanina dipole ani niya. Okay. But this one, we solve it using the general formula. Okay. Meaning the katong dominant term sa dipole lang, we have this formula here. Okay. So next is, how about we want unsa ka ang electric field form sa monopole and dipole. Okay. Let's find out the electric field of monopole and dipole. Okay, so for the monopole term, you have your potential given as total charge over R. Okay, so to get the electric field for the monopole, di ba katong formula na to, if you can recall, we have the negative del V. So given the potential, you can take the gradient, then we can now extract the electric field. So since the potential is in terms only of R, so the other component sa imuhang del or gradient will not contribute. So di siya apilon. We have negative V over R, okay? So we have partial R. So we have 1 over 4 pi, where V is this, 1 over 4 pi epsilon naught Q over R. So this would be 1 over 4 pi epsilon naught. So ang derivative sa sulod is just with respect only to R. So these are just constant, the Q and the 4 pi epsilon naught. So the derivative of 1 over R with respect to R is just negative 1 over R squared. So this would be Q over R squared na. So mawala ang negative sa gawas. This is negative. So kani pag derivative nimo it's negative, so it becomes positive. And notice that this is R hat. So notice that the electric field direction or orientation of a monopole is dependent only on the R. Okay, R direction. So meaning to say, ang imuhang, let's say you have a point charge, the electric field is only, kumbaga yung orientation is only on the R hat direction. So direction sa kung asa ang R. So let's say this is R. So it will not change direction. So dito na gina siya permi, right? Radially outwards. So if we have this, dito na po na siya permi. Wala siya curvature. Straight lagi siya. Right? Divergent. That's why nana imuhang electric field if you have a point charge. Right? Mama ni ato ang elementary lesson, diba? Or high school nga lesson, na or basic na to nga understanding on electrostatics, that the electric field of a positive charge is given by this. Ganun. okay? Because this is the electric field and it's dependent only on r hat, okay? Now, how about sa kay shape sa electric field sa dipole, okay? And then we have two types of electric field sa dipole. We have the pure dipole and the physical dipole. And you will notice later on nga, they will look as similar but not the same. Okay? So let's find out. Let's recall first the dipole sa the potential sa dipole. We already calculated this one in the previous earlier. So we have r hat dot p over r squared, or this is just 1 over 4 pi epsilon naught p cosine theta over r squared. Okay, so that's your dipole. And then to get the electric field, you have to take its gradient, right? So gradient siya. But since if you look at the potential of a dipole, it only depends on r and theta. So it has no dependence on the phi. So symmetric siya along the phi nga angle. Okay, so just r theta. So we can get the electric field, the r component of the electric field. So we can have this. And if we take the derivative of your dipole potential with respect to r, so you will find out it's just 2p cosine theta over 4 pi epsilon naught r squared. No, r cube, I mean. Okay, squared naman na daan diha. So pag i-derive mo na siya, becomes cube. Okay? For the theta part, so we have 1 over r, partial of v, partial of theta. So that equates to p over r cube. Okay? So that would be p over r cube sine theta. And of course, the EP, so the general formula actually for the EP is just E phi or whatever, so P or phi, r sine theta, P. Okay, that's 0. So wala siya angle phi dependence. Okay, so simplifying this one and combining the r and theta component of your electric field, so we have this. So electric field sa dipole is just combining similar terms, 4 pi epsilon naught r cube. We have 2 cosine theta r hat plus sine theta theta hat. Okay, so that would be the electric field. So how will this look like given the formula for our electric field sa atuang dipole? Sa kahit itsura sa imong electric field. Okay, so we can actually draw it because naa naman tayo equation. So if you plot it on any software yung gamiton or maybe programming language, say MATLAB or Python or even C++ or C. So if you plot this one, you will find out na ang iyahang potential, iyahang electric field direction or form or pattern is given by this. So ako na siyang i-insert. It's actually na to at insert picture. How do I do it? Okay. Actually, here. Tara. Tara. How do I, ano ni? So, move. Okay. Okay. So, di na siya ma-move. So, diha na lang na siya. So, I have the electric fields among pure dipole and a physical dipole. So, it's actually similar. So, as you can see here, the electric field is dependent only on the R and the theta. So, ang pag-curvature niya is naa siya with respect sa theta. Okay? But there is no phi dependence. Okay? So, phi niya, ang phi niya is zero. So, that's why inana siya ang iyang uh, imong direction. Okay? So, always man na siya nga ang electric field mo is directed from the positive towards the negative pole. Okay? It's like this. So, similar siya sa imong pure dipole na it's like a point siya. So, kumbaga mas stronger lang iyang field lines because it's like a point. So, nasa sa origin, right? So, that's it. The uh, that culminates or that's the end of our discussion on special techniques in calculating the potential, specifically on uh, expanding the potential in terms of the powers of 1 over r, or in terms of the contribution of the monopole, dipole, quadrupole, octopole, and so on. So for this case, nag-stop lang ta sa you have a pure dipole, you have a monopole and a dipole because mao naman na siya ang murag dako ay contribution if you have a charge distribution. So in our next topic, we'll be discussing on uh, physical or example gid niya ba, let's say in real life about dipole and maybe other terms, right? So we'll be discussing on electric fields in matter. Okay? In actual di siya nga matter ba, let's say what will happen to your matter, example of a matter nga of great significance is the water. Okay, we have a water molecule. What will happen if that will be subjected or exposed to an electric field? Okay, at saka ang iyang reaction sa imuhang water naa ba? So if naa, unsa iyang reaction, will will the water molecule behave some behave something differently? So if that's the case, we'll be able to calculate in great detail regarding sa iyahang electric field, if puproduce ba siya dipole moment, and so on. Okay? So see you on our next video and cheers. Stay safe and God bless.